Hello everyone, for subject DCC30122 fluid mechanics, we are going to do a presentation for topic 3, which is hydrodynamic. The subtopic that we will discuss is uniform flow and steady flow. Assalamualaikum, my name is Nurdiana binti Alitama with metric number 08DK21F1189.
My name is Nurin Farhana binti Nur Hisham with matrix number 08DKA21F11X0.
Hi, my name is Siti Nurhidayah binti Mat Gadar with matrix number 08DKA21F1171.
And me, Nurul Aisyah Masara binti Ma'ali with matrix number 08DKA21F1176.
Behavior of fluid flow divided into two, which is closed channel and open channels. Closed channel also has two parts, which are steady flow and unsteady flow, and it's a pipe. A steady flow is the one in which the quantity of liquid flowing per second through any section is constant.
The second part is open channel. Open channel are divided into two, which are uniform flow and non-uniform flow.
Next, steady flow in closed channel is fluid characteristic will be differ from point to point but do not change with respect to time. The fluid characteristics are equal to velocity, density, pressure, temperature, and discharge. The diagram on the left shows an example of steady flow V against T.
And now, I will explain the unsteady flow. Unsteady flow is a flow characteristic at any point change with respect to time, and the quantity of liquid flowing per second through any section is not constant.
Example diagram: steady and unsteady flow. The flow in which characteristic of fluid like velocity, temperature, pressure, density, and others do not change at a point with time is known as steady flow. The diagram below, steady flow, shows that velocity 1, temperature 1, and pressure 1 at T1 equal to T2.
For unsteady flow example diagram, at time T1, velocity V1, temperature T1, and pressure P1 different at time T2, velocity V2, temperature T2, and pressure T2.
The fluid characteristics are velocity, pressure, density, and etc. Uniform flow happens when the fluid characteristic does not change with time, and the magnitude and direction at every point in the fluid are remain same.
Next, I will be discuss about non-uniform flow. Non-uniform flow occur when the stream enter and leave the channel, and obstructions such as dam, well, or bridge burst, and a change in the form of cross-section which may be necessitated by natural condition of soil and topography. When the velocity and other hydrodynamic parameters change from one point to another point, the flow is defined as non-uniform. There is two important points. The first one is for a non-uniform flow, the change in position may be found either in the direction of flow or in direction perpendicular to it. The second is non-uniform in a direction perpendicular to the flow is always encountered near solid boundaries past which the fluid flow.
At first, the fluid is in a uniform flow when its characteristics such as velocity and the magnitude remain same, but after it hits the rock, the velocity and magnitude change, and the fluid spreads into a different direction. Hence, it becomes a non-uniform flow.
As a picture given instead, the speed and direction is different at every point. That means the velocity is not the same at every point. This flow can be defined as non-uniform flow.
But rather than just see the drawing, we can see this more clearly by looking at an example in the fluid. We can see in this example that the main flow parameters are not changing with time, as the stopwatch continues. We can clearly see that the depth, and therefore the cross-sectional area,
are remaining constant if the depth is stable with time for an open channel flow. This gives us a very good indication that the system is in equilibrium, and therefore the discharge and velocity are also not changing with time. This is a steady flow because the main parameters are not changing with time. However, if I turn the supply pump off, this will now create unsteady flow, as the discharge, velocity and area will now change as time goes on. Here we can clearly see that the depth and therefore the cross-sectional area are dropping as time goes on. So this is now an unsteady flow. That is the end of the presentation. Thank you for watching.